Imagine asking a neural network to draw a box around an object with no hints at all. Any position, any size, any shape produced straight from a blank slate. That open-ended target turns out to be genuinely hard and unstable for a network to learn because there are simply too many possible boxes and nothing to steady the prediction. So the detectors that shaped modern object detection, faster RCNN, SSD, and YOLO version 2 onward, reached for a clever trick that quietly reframed the whole problem. Instead of predicting boxes from scratch, they start from a set of predefined reference boxes called anchor boxes and merely refine them. Today we're unpacking what anchors actually are, how they work at each location, and why they made fast, reliable detection possible in the first place. To really see anchors, follow what happens across a feature map, one location at a time. It starts by tiling reference boxes. Detectors predefine a set of anchors in several scales and aspect ratios: tall, wide, square, small, and large, then stamp that same set densely at every location of the feature map. Thousands of candidate boxes now blanket the whole image. At each anchor, the network asks a simple question: does a real object actually sit near this box? It predicts an objectness or class score for every anchor, flagging the small fraction that look promising and marking the vast empty majority to ignore. For the promising anchors, the model predicts small offset adjustments. Rather than inventing a box out of nothing, it simply nudges the anchor's center, width, and height so the reference snugly fits the actual object underneath it. Predicting a small correction to a box that's already roughly in place is a far easier and more stable target than open-ended prediction from scratch. Keep and refine the good ones, and you get final boxes. During training, each anchor is matched to a ground truth box by IOU. High overlap counts as positive, so one forward pass quietly considers many shapes and sizes at once. So why bother predefining boxes at all? Compare the two ways a detector can produce a box. Predicting each box from scratch means the network must output an arbitrary position, size, and shape with nothing to anchor against. That open-ended target is hard to learn and unstable in training, because tiny errors early on send the predicted box wandering far from any real object. Anchor boxes turn that into refinement. Start from sensible predefined references, and the network only has to pick the good ones and nudge them into place. Now, that reframing is exactly what let one clean forward pass handle objects of many shapes and sizes reliably. Now, 3 ideas capture how anchors work and what they cost you in return. First, predefined references tiled across the image. A fixed set of boxes in many scales and aspect ratios covers every location densely. So wherever an object appears, some anchor already sits roughly nearby and ready to be adjusted. Second, a score plus offsets at each anchor. The detector predicts whether an object is present and how to reshape the anchor to fit, turning detection into a manageable per-anchor decision rather than one impossible global guess. Third, it works but needs tuning. Anchors genuinely made detection fast and reliable, yet they carry real baggage. Many hand-tuned hyperparameters like the exact scales and ratios, plus a sea of mostly empty, imbalanced boxes where almost nothing sits. Those downsides later drove a wave of anchor-free detectors, such as FCOS and CenterNet, and eventually the transformer-based DTR. All right, let's lock in what anchor boxes really contribute to object detection. Anchor boxes are predefined reference boxes of many scales and aspect ratios tiled densely across the feature map. At each anchor, the detector predicts whether an object is there in small offsets to reshape onto the real object. That turns box prediction from scratch into an easier refinement problem, letting one pass cover many shapes at once. Anchors powered faster RCNN, SSD, and YOLO, though their tuning burden later inspired anchor-free designs. To keep building this kind of computer vision intuition, visit standardy.com for more clear explainers.